Hey there, Mr. Sutton here with the AB Calculus Derivative Extra Practice number 5 solutions. On this problem, we're going to have to use the product rule. So taking this derivative, we've got u prime v plus uv prime. And now the box and ribbon will help us sort all this out. We have the two factors, x to the 5th and sine of x. Derivatives of those are going to be 5x to the 4th and cosine of x. And then using the ribbon to put it back together, we have 5x to the 4th times sine of x, that's the u prime v, plus x to the 5th cosine of x. For this problem, in order to take the derivative, I'm going to need to use the quotient rule. So I've got u prime v minus uv prime all over v squared. Here's the box and ribbon to help us keep things organized. I have my numerator, x, and then over here I've got the denominator, 3x to the 4th plus 5 cubed. And now the derivatives will go down here. Derivative of x is just 1. Derivative of this expression, well, this is going to require the chain rule. For my outer function, I've got something to the 3rd power. Derivative of that is going to be 3 times the something squared. And now we have to multiply by the derivative of that something of 3x to the 4th plus 5. That's going to be 12x to the 3rd. All right, let's put it back together using the ribbon. So we've got, let's see, 3x to the 4th plus 5 cubed, and this will be inside a big fraction here. And then going the other way, we've got minus 3x to the 4th plus 5 squared, and then 12x cubed. I'm not going to simplify it any more than that. And then down below, we've got v squared. So squaring this term is going to give us 3x to the 4th plus 5 quantity raised to the 6th power. And then we'll just call it a day on this one. To take this derivative, we're going to have to use the chain rule, but maybe not as much of a chain as you might have thought at first. If you look in here, ln and e are going to cancel out. So this is actually cosecant of just x cubed plus 2, if we want it to be. So now I've got the cosecant of something. Derivative of that, that's going to be cosecant, or actually negative cosecant of something, cotan of something. The something being this x cubed plus 2. So we have a cosecant and a cotan part, and it's all negative. And we have to multiply by the derivative now of x cubed plus 2. So that's going to be a tail of 3x squared. For this problem, taking the derivative, I'm going to use the chain rule. My outermost function, I have 4 to the something. Well, that derivative is going to be 4 to the something, to the tan 2x, times ln of 4. Next, I multiply by the derivative of tangent of 2x. Well, that's really just a tan of something kind of situation. So using the chain rule there, we have secant squared of 2x times the derivative of 2x, which is 2. For this problem, this is looking like it's going to have two crazy quotient rules with chain rules built into them, all of it added together. Before we go down that road, though, we can actually simplify this a little bit. So secant, remember, is 1 over cosine squared. So if I divide by 1 over cosine squared, I'm really multiplying by cosine squared. That gives me cosine to the 4th power x. And then over here, we can do pretty much the same thing. Sine is really the reciprocal of cosecant. So if I move all this upstairs, that's really a cosecant squared times another cosecant squared, which is cosecant 4th power. So it's still going to take a little bit of work, but now at least I don't have to use the quotient rule. So taking a look at this first one, we are going to have to use the chain rule. The outer function is the 4th power. So this is going to be cosine cubed of x, with a 4 out in front, times the derivative of cosine, which is negative sine. And then over here, we're going to have 4 cosecant cubed of x, times the derivative of cosecant, which is the inner function here. So that's going to be times negative cosecant x cotan of x. To take the derivative on this problem, it's going to be tricky because we can't isolate y. So we're going to have to use implicit differentiation. So I'm going to take the derivative of everything here, and whenever I take the derivative of y, because it's now being treated as an inner kind of hidden function of x, I'm going to have to multiply it by dy over dx using the chain rule. So on the left side here, we actually start off with a product rule, 6x to the 4th times sine of y. Let me use the box and ribbon to help me with this. So I've got 6x to the 4th, sine of y, those are my factors. Derivatives of those are going to be 24x to the 3rd, and this is going to be cosine of y dy dx. All right, so multiplying it back out with the ribbon, we've got 24x cubed sine of y plus 6x to the fourth cosine of y dy over dx. And that was just the left side of the equation. Now we go to the right side here. Derivative of 62x is 62. And y cubed, that's going to be 3y squared dy over dx. For my next step, I'm going to rearrange this so that everything with a dy over dx is on the left side of the equation, and everything else is on the right side. So this 6x to the fourth cosine of y dy over dx, this can stay on the left. This 3y squared dy over dx, I'm going to subtract that to get it over to the left. And then 24x cubed sine of y, I'm going to subtract that to move it over here to be with the 62 that's hanging out there. So let's just subtract that other term. And at this point, I'm going to factor out a dy over dx on the left side. That leaves me with 6x to the fourth cosine of y minus 3y squared inside. I still have to isolate dy over dx. So to do that, I'm just going to divide both sides by this parentheses. So I have 62 minus 24x cubed sine of y over all that stuff. And that's going to end up being my final answer for this one. For this problem, I'm going to use the quotient rule to take the derivative. So that's u prime v minus uv prime over v squared. And let me use the box and ribbon to keep things organized. So my numerator, I'm going to put that over here, x squared minus 6 to the third power. Denominator will go over here, so that's 3x plus 5. And now the derivatives of these things. This one I'm going to need the chain rule. So I've got 3 times something squared, 3 times x squared minus 6 squared. That was the derivative of the outer function, times derivative of the inner function, so times the derivative of x squared basically, which is 2x. Over here, derivative of 3x plus 5 is going to be 3. And now using the ribbon to put it back together, I've got the stuff in the lower left here times 3x plus 5 on my big fraction here. And then we're going to subtract and go the other way on the ribbon, getting 3 times x squared minus 6 to the third power. And down below we've got 3x plus 5 squared, because this is really v squared down here. For this problem, I'm going to need the quotient rule to take this derivative. So I've got u prime v minus uv prime all over v squared. That's my basic format. Here's my box and ribbon to help me sort things out. I have my numerator, ln of 2x, denominator, arcsecant of x, and the derivatives of those. So derivative of this is a chain rule. We've got ln of something, whose derivative is 1 over the something, times the derivative of the something, so that's going to be a 2 that we're multiplying by. And derivative of arcsecant, that's just going to be 1 over absolute value of x times the square root of x squared minus 1. It's a good one to have memorized. Using the ribbon to multiply that together, well, these 2's are going to cancel, so this is just a 1 over x. And we have an arcsecant of x that we can put on top of that fraction. So upstairs here, u prime v, that's going to be arcsecant of x over x. And now going back the other way on the ribbon here, this is the uv prime. This is going to be ln of 2x over all that stuff down there. Subtracting that. And then down below we've got v squared. That's going to be arcsecant of x squared. On this problem, to take the derivative, I'm going to need the chain rule. I've got my outer function as 3 to the something. That derivative is going to be 3 to the something, or 3 to the arcsine of x, times ln of 3. Now I have to multiply by the derivative of arcsine, which is just 1 over the square root of 1 minus x squared. For this problem, I'm going to need to use the product rule to take the derivative. Before I do that, though, remember that log base e really is just ln. So I'm just going to rewrite that as ln so I don't have to use the specific log rule that's not ln based. All right, let's use our product rule now. That's u prime v plus uv prime. Box and ribbon time. We've got our first factor, 5e to the 2x. And then this ln of 4x is going to be the other box here, the other factor. Derivatives of these, this is going to be 5e to the 2x times a tail of 2, so you could call it 10e to the 2x. This one is going to be 1 over 4x times 4, so that's going to just be 1 over x if you simplify it. So now using the ribbon to put it back together, we've got 10 e to the 2x times ln of 4x. That's the u prime v. Plus, going the other way, this is going to be 5 e to the 2x times 1 over x, or over x, however you want to write it there. And it looks like we're done. For this problem, taking the derivative, we notice first that we have a variable in both the base and the exponent. So we're going to have to use logarithmic differentiation for this. To do that, I'm going to take the ln of both sides. So I end up with ln of y on the left. On the right side, ln'ing everything here, that pops out my exponent of ln of 3x. And I still have ln of the base, which is also an ln. So we have ln of x plus 2. Whole lot of ln's on this one. Now that we've gotten this variable out of the exponent, we're going to implicitly differentiate to get dy over dx by itself. So on the left side, this is going to be 1 over y. But since y is an inner function of x, we have to multiply by the derivative of y, which we're just calling dy over dx. Over on the right side, we're going to have to use the product rule. So let me get a box and ribbon going here. I have my two factors, ln of 3x, and then my other factor, ln of x plus 2. ln of 3x derivative, that's going to be a chain rule. We have the ln of something. That derivative is going to be 1 over the something, 1 over 3x, times the derivative of 3x, so times 3. And then for this one, we've got outer derivative is going to be 1 over ln of x plus 2. And then we're going to have the derivative of ln of x plus 2 that we have to multiply by using another chain rule here. So that's going to be 1 over just plain old x plus 2. There it is. All right. So now using the ribbon to multiply it all back together. Well, let's see here. Going this way, the 3's can cancel. This is just 1 over x, and we've got an ln of x plus 2 on top of that. So there's our first term. And then going the other way here, well, all this stuff down here can go in the denominator, and we have an ln of 3x on top, so ln of 3x over all this stuff down here. And we're almost done, but we still need to isolate dy over dx. We can do that by multiplying both sides by y, so it'll be y times all the stuff on the right side here in one big old parentheses. And they didn't say that you had to get this in terms of x, but if you wanted to, you could replace y with this original function over here. So this would be another version of the final answer, just y swapped out for the original function.